Hey everyone! In this video I'm going to talk about surveys that are based on non-probability samples. Okay? And as we talked about in the previous videos, this is one of the kind of key characteristics of survey research in the age of big data that move from traditional probability samples and telephone-based surveys to non-probability online surveys. Okay, and so traditionally in social science research, there was quite a lot of opposition to um, non-probability samples because there are a lot of kind of historical examples of non-probability samples yielding kind of wrong predictions or wrong estimates of, for example, here president support for presidential candidates. In this case, we had the Chicago Daily Tribune predicting or writing an article based on kind of exit polls or surveys around the election that predicted that Dewey defeated Truman when in fact Truman actually won by a landslide. And one of the that's kind of one of the traditional examples that is brought forward of why non-probability samples are problematic because of systematic biases between the sample and the target population that make it difficult to generalize from the sample to the population. Okay. And so traditionally, in the age of telephone surveys and basic probability samples, where these probability sampling procedures were preferred because roughly the way we can describe probability sampling is that every unit, so every observation respondent in the survey from a defined population or a specific sampling frame has a known and non-zero probability of being included in the survey. And as soon as that is the case, and as soon as we have kind of a known probability of inclusion, we can use this survey and their methods to kind of then weight observations in the survey, even if the probability of inclusion is not exactly the same across all observations, is not exactly the same as in the target population. We can nevertheless weight observations in our sample in order to make relatively accurate inferences about the population based on these probability samples. Okay, so as I said, not all probability samples directly have to be representative of the population. The key is that we kind of have an idea about the probability to be included in the sample, so it's a known probability. And given that known probability, we can apply an appropriate weighting to get unbiased estimates of the frame population that we're interested in. Right? And that's the key strength of probability sampling. Specifically, as it was most applied with telephone surveys. Okay, but the problem is, and this is some of the discussion in the Groves paper, that these telephone surveys and the kind of the traditional probability sampling methods are becoming more and more difficult to actually implement because we have decreasing response rates in telephone surveys, for example. We have fewer and fewer landlines, which makes it harder to apply these random digit dial mechanisms or methods. So kind of actually implementing true probability samples with a high enough contact rate is actually increasingly difficult and costly, right? So ultimately, and at the same time, there are there are methods that are being developed to allow us to use non-probability samples and kind of adjust the estimates that we get from non-probability samples to still make inferences about our target population by basically including information from other additional sources and including information from, for example, like census and other sources. Okay, so ultimately, the way kind of survey research is developing is that probability samples, due to decreasing response rates and related issues with phone surveys, for example, probability samples become either prohibitively costly, or even if they can be implemented, there's still so many or such a large proportion of non-response that ultimately we're still left with somewhat of an unknown sampling process, similar to non-probability sampling. And ultimately, both non-probability samples and probability samples need to use some sort of weighting to achieve kind of valid or unbiased estimates of our target population. Okay. So to give you one example of non-probability samples being used in order to kind of provide unbiased and accurate predictions and estimates of a quantity of interest in the target population, I'm going to talk a little bit about this paper by Wong and others titled Forecasting Elections with Non-Representative Polls. And this paper is really interesting. I'm going to post this on Canvas as well if you want to take a closer look, because this paper uses survey data from a clearly non-probabilistic sample, namely Xbox users. So they ran surveys. The researchers ran surveys on with Xbox users through the Xbox, basically, and asked people about their preferences, specifically in the 2012 election, and and the goal was to predict, prior to the 2012 election, predict the outcome of the 2012 election. Okay, and of course, as you can imagine, Xbox users are not in no way, shape, or form representative of the overall population in the United States. They're more likely to be male, they're more likely to be younger, for example. But nevertheless, if we kind of gather that information and reweight, find a method to kind of adjust for these differences, we can still make accurate predictions of support for presidential candidates, in this case Obama and Romney. Okay. Specifically, what this paper is doing, or what the researchers are doing, is they're using multi-level regression and post-stratification, which is something that we talked about a little bit in one of our Q&A sessions, actually. So the underlying idea here is that they're using, they're basically combining the survey data that they have. They're splitting up the survey data into different cells that are that are assumed to be homogeneous within those specific sociodemographic characteristics, right? So, for example, you could think of men of a given age group with a college education from Wisconsin, who identify as Republicans or something like that, right? And then we predict, using a multi-level regression, we predict support for Obama versus Romney for that specific cell. And then we use basically additional information from the census about the size, the relative proportion of each of these cells. So how many male voters of that age group who are college educated, live in Wisconsin, and are registered Republicans, and then use that information to kind of extrapolate and kind of weight or stratify, so to speak, to provide an estimate of the overall support for Obama versus Romney. Okay, so the underlying method, as I said, is multi-level regression and post-stratification, or Mr. P. And what these researchers show is that even though the original sampling data, so the unweighted results here estimated support for Obama in 2012, using just the unweighted sample of Xbox users is of course widely off when it comes to predicting support for Obama in 2012. This is an overtime change leading up to the election, and the dashed line here is of course the actual ultimate election result in terms of the popular vote. But the important thing is that once you go through this multi-level regression and post-stratification method to kind of adjust for the imbalance in the sample and kind of use the information about the relationship between the social demographics and support for Obama, and then reweight according to the actual makeup of the target population, which is in this case the US voting age population, you actually get a prediction, this is now Xbox weighted, that is much closer to the final result than here pollster.com, so an aggregate of probability-based or survey predictions based on a traditional probability-based sampling, right? So kind of the lesson, and this is an interesting. Just wait a second. The link will be in the slides that I'm going to post on Canvas as well. Kind of the takeaway message here is that non-probability sampling doesn't necessarily have the flaws, or doesn't necessarily suffers from the flaws from these historical examples that show that they can be, lead to wrong conclusions and can be ultimately biased, but rather that they're kind of the future of survey data collection, because telephone surveys are becoming increasingly costly, response rates becoming lower and lower, and so we have to kind of find new techniques, and these new techniques are based on non-probability samples like opt-in online surveys, things like asking Xbox users, for example, in this case, and then using methods like multi-level regression and post-stratification to adjust and kind of reweight these estimates in order to approximate or provide unbiased estimates for our target population. And this is a blog post that you guys should check out by one of the authors, Andy Gelman, talking about kind of this opposition in traditional survey research against non-probability sampling, and this kind of insistence on probability sampling as kind of the only valid method to in survey, or the only useful method in survey research, and kind of a tongue-in-cheek title, kind of comparing that to the president of the American Association of Buggy Whip Manufacturers takes a strong stand against internal combustion engines, argues that the so-called automobile has little ground in theory. And of course, these little ground in theory and results can vary widely based on particular methods that are used. That's kind of the quote from traditional survey researchers, right? So the message here, check out the post and give it a quick read. The message here is, of course, that there's skepticism in kind of survey research against non-probability sampling, but the skepticism is ultimately misguided, and there are useful methods that are ultimately kind of the future of survey research in kind of the digital age. Okay. So this was one example, and as I said, feel free to check out the original paper as well as this blog post. This is one example of using non-probability samples where we don't really know there's no known probability of inclusion from the target population in, for example, these Xbox surveys, because people opt in, they choose, to buy, an Xbox and so on. But by using statistical techniques like multi-level regression and post-stratification, we can still recover unbiased estimates of quantities of interest in the target population, right? And so if we think about kind of, traditional surveys and probability sampling on the one hand, and non-probability sampling and these online-based methods, and kind of put them on a spectrum with regard to their cost for researchers and the error that we see, or the potential bias, we could kind of put them in this kind of in this two-dimensional grid, so to speak, where for a very long time probability sampling was the most accurate method to for example, to get accurate estimates or unbiased estimates of, for example, in this case, presidential or political preferences and things like that. But with these problems like reducing response rates and things like that, what we're seeing is that probability sampling using, for example, telephone surveys is both becoming increasingly costly and becoming more and more error prone, because there are more and more there's a larger and larger gap between our sampling frame itself and the people who actually end up in the sample itself. Okay, so probability sampling and kind of traditional survey research is becoming increasingly costly and also increasingly error prone, where non-probability sampling and methods like the one that I just talked about briefly, as of now, might be potentially more error prone, might be not, in some cases more biased, or there might be more variation. But if we're looking at the trajectory of where these techniques are going, they're becoming less and less costly. They're already less costly than face-to-face or telephone surveys, but the errors are becoming smaller and smaller. Our techniques to kind of nevertheless kind of recover unbiased estimates of our target population are becoming better and better, right? So going forward, there will be more and more non-probability sampling, and using methods like Mr. P is useful in kind of recovering quantities of interest about the target population. Okay. So just to summarize, Mr. P, or multi-level regression and post-stratification, is just one of the many ways to post-stratify non-probability samples in order to get estimates about the population. And ultimately, the performance of Mr. P and related methods is an empirical question. But these methods are becoming more and more sophisticated, and as we've seen in this example, closer and closer to our actual target, or bring us closer and closer to our actual target population, even if we don't have a true probability sample. Yeah, of course, these methods can be applied to big data and experiments. I should say there are also methods that focus on sampling rather than reweighting and post-stratification. Okay, so there's a lot of new developments in this context that kind of help us use non-probability samples. Okay, so the idea is, going back to the Truman election, we shouldn't let what happened in 1948, the fact that non-probability samples yielded very inaccurate predictions of for example presidential election results, should not prevent us from trying new things today, especially given that new statistical methods exist to kind of help us provide more accurate estimates. Okay. All right, that's it about non-probability samples. In the next video, I'm going to talk about computer-administered interviews.